Hello and welcome again to Argo Prep. We're going to be covering the greatest common factor. Remember, this is important. Don't confuse the strategy on how to approach greatest common factors with the least common multiple. They're similar, but very different.
Okay, so we're talking about greatest common factor in this video. To find the greatest common factor, there are obviously two ways to approach to find the GCF of a set of numbers. The first way is going to be similar to how we did for the last video, which was finding the least common multiple. It is not the recommended way unless the question is obviously easy. And the second way is going to be an actual rule that you have to follow. So first of all, even before I start with an example, what is the greatest common factor? Well, the greatest common factor is simply any integer, or I should say a positive integer, that divides evenly into all the numbers in the respective set. So that means it has no remainder. What does that exactly mean? So let me show you an example. Let's just say, hey, what is the greatest common factor? So let's just say, what is the greatest common factor of 48, 24, and 36? Well, the first way I can go ahead and do this is say, okay, you know what, let me go ahead and do it the traditional, not the traditional way, but the way that most students are used to at a lower level, let's just say. So I will list out 48, 24, and 36, and I'm going to think to myself, what are all the factors of 48? Well, I know that 1 times 48 is 48, meaning that 1 and 48 are both factors of 48. I know that 2 times 24 is also 48. I know that 3 times 16 is 48. I know that 4 times 12 is 48. And I also know that 8 times 6, or rather 6 times 8 is 48. And I believe those are all my factors of 48. Yes, I didn't miss any. 24, the number 24, what are the factors of 24? Well, 1 and 24, because 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is going to be 24 as well. And those are all my factors of 24. You can already see that this is taking a long time, right? Because even if I'm not familiar or that comfortable with my multiplication table, which you certainly should be, it's already going to slow me down, right? So 36, what are my factors of 36? Well, 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is also 36, and finally 6 times 6 is 36. Don't forget about that. And those are the factors of 36. So now we're looking for the greatest common factor that basically will divide evenly. That simply means that, hey, what are the common numbers here? Well, I know that 1 is common, but hey, 1 is not the greatest common factor here because I also have 2. Well, I also have 3. Simply, we want to start looking basically around this area over here to try to see what the greatest common multiple will be. And if you take a look at it, I see that the number 12 appears in all 3 numbers over here. And that's it, right? 16, 24, 48 do not appear all 3 anywhere here in the other 2 sets. That means that the greatest common factor of the set of 48, 24, and 36 is going to be the number 12. And that is the first way that you can possibly do this question. Obviously, it does take a little bit of time, but once again, I would not recommend this way. Let's go ahead and try it now the second way, which you should be very, very familiar with and comfortable with. Please, I'm going to tell you right now, please don't confuse it with the least common multiple. You have to go ahead and make sure you don't mess up the technique for finding out the GCF and the LCM. A lot of times I see students mixing up the two because they're not sure. Remember, for the least common multiple, you're taking every number in each set that appears throughout the most frequently. For the greatest common factor, it's going to be a little bit different. So let's go ahead and do this. Let's go ahead and actually clear this so I have I have more space to show you. So the GCF of 48, 24, and 36, and as you can suspect already, I'm going to go ahead and do the prime factorization tree chart, right? So 48, 24, and 36. Think 48, I'm trying to get all the prime numbers. 12 times 4 is going to be 48. 2 times 2 is 4. Those are prime numbers. 4 times 3 is 12. 3 is a prime number. I can further break down the 4. 2 times 2 is 4. And now I have 48. So 48 is over here. And it's going to be 2 times 2 times 2 times 2 times 3. How about 24? Okay, let's see. 24 can be broken apart into 12 times 2. 2 is a prime number. 12 can be broken down further into 6 times 2. 6 can be further broken down to 3 times 2. I have now 2 times 2 times 2 times 3. 2, whoops, let's go ahead and stick with our red color over here. 2 times 2 times 2 times 3. And then finally, I have 36 over here. 36 can be broken down to 6 times 6, which is 36. 3 times 2, 3 times 2. And now I have 2 times 2 times 3. Once again, let's stick with the red color. Sorry about that. 2 times 2 times 3 times 3. Okay, great, right? This is the same exact way we've been doing also for the last video in the least common multiple, but now the technique is different. Write this down. For the greatest common factor, you're only going to take the numbers that appear in all sets that are common the most amount of times. What is it? Not the most amount of times, sorry, the same amount of times. What does that mean? Let me go ahead and clarify. Let's look at the number 2. The number 2 over here appears 4 times. The number 2 over here appears 3 times. The number 2 over here appears 2 times. Now, ordinarily, in the least common multiple, you would take 2 4 times, but in the greatest common factor, you're only going to take it 2 times. Why? Because this the prime factorizations of 36 only has 2 2's, and you're only allowed to take numbers that are common in all the sets. So in all sets, I have at least 2 2's over here. So it's going to be 2 to the second power. I can't take any other 2's because in my set over here, I don't have any other 2's. How about for 3? Try this one yourself. Well, I have 1 3 here, 1 3 here, 2 3's here. It doesn't matter that I have 2 3's here. In all my sets, I have at least 1 3, so I'm going to only take 1 3. I don't take this extra 3. So it's going to be 2 to the second power times 3. 2 to the second power is going to be 4. 4 times 3 is going to be 12. And this is the greatest common factor. 12 is the greatest common factor of the set. Obviously, we got the same answer. It is a faster way, especially when you're working with harder numbers. Let's go ahead and take a look at a few more examples so I know that you understand this entire process.
Okay, before we move on to the next example, just very quickly, I'm going to write down the rules for you. Please write this down. So to find the greatest common factor, first, number 1, you have to go ahead and find the prime factors of each number. Number 2, take the highest number of occurrences of prime numbers that are common in all sets. And then finally, number 3, you go ahead and multiply all the prime numbers that are common to find your greatest common factor.
Okay, so the next question, let's take a look at this. Okay, so let me say GCD of 120 and 5. Keep it simple over here, but you guys might be saying, hey, whoa, what's going on right now, right? Why did you write D, right? What happened? I thought it was GCF, right? GCF, greatest common factor, GCF. So the next important thing, so it's very important for you to know that there are multiple ways, there are various ways of saying the greatest common factor. So here GCF stands for greatest common factor. Here GCD stands for greatest common divisor. Write that down. It means the same exact thing, but if you're on your exam, don't get confused because of the wording. Okay, I can write this multiples away, right? I can, first of all, the GRE exam will not just have the question in this form. It would be far too easy, first of all. But let's just see other ways that it could potentially be seen on the exam. Perhaps I can say X is the GCD of 120 and 5. That means that you're trying to find X, and X is going to be, of course, the greatest common divisor, which is also the greatest common factor. I can also say X is the highest number which divides 120 and 5. It means the same exact thing. X is the highest number which divides 120 and 5. I'm just rewriting this, and I'm not saying straight out it's find the greatest common factor, but it's the same exact thing. You would take the same exact approach. I can write something else. I can say X is the HCF, highest common factor. Instead of greatest common factor, I can say highest common factor. of 120 and 5. So write these down, okay? So there are multiple ways we can have GCD, greatest common divisor, GCF, greatest common factor. I can say the highest number which divides. I can say highest common factor. So once again, there are various ways that the test can try to test you on this subtopic over here. The main point here is please don't get confused with the wording. So let's go ahead without further ado and actually do this problem to find the GCD, let's say now, greatest common divisor. So GCD of 120 and 5. Looks easy? Yes, it is easy. We're going to start off with easy questions, and the next question, of course, I will give you something more challenging. 100. Go ahead and do it. 10 times 10. 5 times 2. 5 times 2. These are my prime numbers. How about 20? 5 times 4. This is a prime number. 2 times 2 is 4. And then finally, well, the 5 is already a prime number, so that's a prime number in itself. So what are the prime factors of 100? Well, it's going to be 2 times 2 times 5 times 5. 20 is going to have 2 times 2 times 5, 2 times 2 times 5, and then finally 5 simply has only one prime factor, which is going to be 5. Now think back to the rules, right? Think back to the rules you wrote down in your notebook. What does it say? You have to go ahead, take the highest number of occurrences of each prime factor that is common to all sets. Okay, well, is the number 2 common to all sets? We have it here, we have it here, we don't have it here. So therefore, you don't take the number 2. How about the number 5? That's the only other number we have left. Yes, I have a 5 here, a 5 here, and a 5 here. And there you go. That's it. Simply, this is your answer. The greatest common factor or the greatest common divisor of 120 and 5 is simply going to be 5. And that's your answer.
Awesome lesson. Okay, that means by the end of this video, you should know how to approach greatest common factor questions. Know the two different methods. Once again, obviously, you want to use a prime factorization way on the GRE exam because chances are you'll be given a difficult or a challenging question that has to deal with GCF. Or perhaps they'll combine both least common multiple and GCF. Please make sure you know all the different ways they can ask you on how to find the greatest common factor. Be comfortable with these two topics. It's easy, but just once again, as we have seen in challenging questions, they can be a little bit more tricky because they don't just come straight out and tell you, hey, find the greatest common factor of two numbers. If you're still not understanding a concept or a particular concept in this video, please feel free to use our free support system at Argo Prep. See you in the next video.